Uh, there is a problem in Munkres Exercise, Chapter 2, question number 3, and it says that let X and X dash denote a singleton set with two topologies. By singleton set means they are same, मतलब X is equal to X dash. But they have given different notation because they X and X dash have different topologies, tau and tau dash. A same set like can have R lower limit topology, R usual. So the same set R can have different two topologies, just like that. So they are asking that let I is a map from X dash to X, and it is identity map, simple identity map. I X is equal to X. We need to show that I is continuous if and only if tau dash is finer than tau. And the second part is show that I is a homeomorphism if and only if tau dash is equal to tau. So we begin the solution. Okay, first of all, I is continuous from the definition of continuous if and only if for every open set U in X, I inverse U is open in X dash. From the definition of continuity, nothing is done. Now see what is this? This is identity map, so inverse is same as U. This is U, which is if and only if I is continuous, if and only if for all U open in X, U is open in X dash. What does this mean? This simply means that if U belongs to X with topology tau, implies U belongs to X tau dash. Thus, tau dash is finer than tau. And hence, how can we write this? Tau is a subset of tau dash. Okay, now if I from X dash to X is continuous, from the first part, we learned that I is continuous if and only if tau is a subset of tau dash. Now, the same identity function from X to X dash is continuous if and only if tau dash is a subset of tau. Thus, this is the inverse of I here. This is I inverse. Thus, I is a homomorphism I is a homeomorphism if and only if from these two, tau dash is equal to tau. So if the both topology are same, then then only then the identity map is a homeomorphism. If you just want to see an example, you know that R usual lies in R lower limit topology. So what does this says that? This says that I from R lower limit to R usual is continuous, but identity from R usual to R low limit is not continuous. So there's another interesting fact we can learn from this. So we have seen that the identity map from RL to RU, identity map Ix is equal to X, is continuous, but Identity map from R usual to R low limit is not continuous because we have R usual is contained in RL but not inverse, but RL is not contained in R usual. Therefore, this is not continuous. So we have an example of a map which is 1 1 onto continuous, but inverse is not continuous.